Good afternoon, students. Today we are going to talk about sulfur and its compound. So this is a simple diagram showing how sulfur it is obtained from underground. So the first thing that you need to know where sulfur is found, where you can find this sulfur, where it's found. So first, we have sulfur can be found in petroleum gas. Then we have two sources where this sulfur is obtained. Then two natural gas. So now let's talk about its occurrence. This sulfur it can occur mostly in metallic sulfides. This is taught in Form 4 methods, whereby you are going to talk about the metallic sulfides. And we have one, galena, which is lead sulfide. This is well taught in method Form 4. Then we have a zinc blended, iron pyrites, copper iron sulfide, and etc. Zinc blended, then copper iron sulfide. These were the metal sulfides that can be used to obtain sulfur. So now let's talk about its extraction. And this is a simple diagram showing how this sulfur is extracted. First, you must have three pipes. The three pipes, the middle pipe is the one that carries or drives water inside the sulfur bed. The pipe that is in between, which contains hot compressed air. Then on your right, you are going to have a pipe which contains superheated water. Then on your left, you will have a pipe that will remove molten sulfur from sulfur bed. So the outer pipe contains superheated water. This outer pipe, this one contains superheated water at about 160 to 180 degrees Celsius. 160 to 180 degrees Celsius. This is the temperature at which that superheated water is. That temperature is between 160 to 180 degrees Celsius. So then this sulfur melts at 112 degrees Celsius. Because sulfur melts at a lower temperature at 116 degrees Celsius, this sulfur that is underground, we are going to use a high temperature so as to melt the sulfur that is underground. The inner pipe with a diameter of 2 cm carries compressed hot air, which forces the mixture of molten sulfur and water up. So the function of the inner pipe, that is the question there. The inner pipe contains hot compressed air which forces the mixture of molten sulfur outside. This hot compressed air, the inner pipe, this is the inner pipe, it contains hot compressed air which forces the mixture outside. This hot compressed air forces this mixture outside, the mixture of molten sulfur and water. Molten sulfur and water. So, the function of hot compressed air forces the mixture of molten sulfur and water outside through the outer pipe on our left, this pipe at my left hand side. So, another thing that you need to take note of, so when these all processes are done, this molten sulfur is going to be collected in a certain tank at this place. This is why you are going to get molten sulfur from there. Then now let's talk about allotropes of sulfur. Allotropes of sulfur. The allotropes of sulfur. So, allotropes of sulfur. We have two allotropes of sulfur. The definition of allotrope you were taught in Form 2. You can go and revisit your notes. So first we have rhombic sulfur, then monoclinic sulfur. These are the two allotropes of sulfur. The two allotropes of sulfur. So now let's talk about rhombic sulfur. Rhombic sulfur. This rhombic sulfur, the things that you need to take note of, you should know some of the features. You have the features, then how it is prepared. How it's prepared. So let's start by looking at some of the features of this rhombic sulfur. So first, the first feature, it is stable below 96 degrees Celsius. Stable below 96 degrees Celsius, that is the first one. Then it is made up of simple molecular S8 rings. Simple molecular S8 rings. Then more stable than monoclinic sulfur because of those interlocking sulfur rings. The sulfur rings are the one that I'm saying, the S8 rings. It is abbreviated as S8 rings. This is sulfur rings. So another one, bright yellow crystalline solid with octahedral shape. Its shape is octahedral shape. Octahedral shape. So how is it prepared? This is another obvious question that you can also be asked in an exam. Describe how rhombic sulfur it is prepared. Probably 3 marks. First, place 2 spatula of powdered sulfur in a boiling tube. 2 spatula. Place 2 spatula. 2 spatula of sulfur in a boiling tube. This is the first step. The first step is place 2 spatula of powdered sulfur in a boiling tube. Place 2 spatula of powdered sulfur in a boiling tube. So next, stir and filter stir and filter the content of the tube until stir. You have to stir and filter the contents of the tube into dry. Stir the content until it dries up. Stir the content until it dries up. So we are stirring it so as to remove the excess sulfur. That's why we are stirring the content. Then allow the filtrate to evaporate slowly. Allow filtrate to evaporate slowly. You have to allow the filtrate to evaporate slowly. Then use the hand lens to examine the crystal formed. Use the hand lens to examine the crystal that is formed. So when you use your hand lens, the crystal that will be formed will be, though I'm not good at drawing, but when you focus at this particular point, this is the crystal that is going to be formed when you use a hand lens. That is the crystal that will be formed when you use the hand lens. So as I have said, when you are asked such like a question, in most cases you are going to be given 3 marks, or will be added 3 marks. And 3 marks, this is how it's called. This is the first mark, the second mark, the third mark. You are not supposed to highlight like this in an exam. You just say, just prepare it using a full statement. So now let's talk about monoclinic sulfur. Let's talk about monoclinic sulfur. Monoclinic sulfur. Monoclinic sulfur. Monoclinic sulfur. Monoclinic sulfur, sorry. First, let's look at some of the features. The features of monoclinic sulfur. After that, we are going to look at how it is prepared. How this monoclinic sulfur is prepared. Now let's start by looking at some of the features. So it is pale yellow crystalline solid with a needle line crystal. It is pale yellow crystalline solid. Then the second one has a melting point of 119 degrees Celsius and a density of 1.98 grams per centimeter cube. Here, the difference, now you can see the difference between monoclinic sulfur and rhombic sulfur. First, rhombic sulfur, as we have said, it is the color of rhombic sulfur, it is bright yellow crystalline. Then the color of monoclinic sulfur, it is a pale yellow crystalline. So if you are asked to state the difference, that is the answer that you are supposed to respond with it. So it exists at a temperature of above 90 degrees Celsius. That is transition temperature. The transition temperature, 90 degrees Celsius. The transition temperature is 90 degrees Celsius. So let me write for a simple equation. This rhombic sulfur, then monoclinic sulfur. This is just a simple question of what I want to explain. You have 2 arrows. The transition temperature, 96 degrees Celsius. The transition temperature, this is the temperature at which an allotrope of sulfur changes from one state to another. Now, as you can see from this diagram, not this diagram, this equation that I'm writing, rhombic sulfur to monoclinic sulfur. From rhombic sulfur to monoclinic sulfur, you have to maintain a temperature of 96 degrees Celsius. Then from monoclinic sulfur to rhombic sulfur, the same temperature is required. The same temperature is required. So, the preparation of this allotrope of sulfur, which is known as monoclinic, the preparation of monoclinic sulfur. So first, place some powdered sulfur in an evaporating dish and heat gently until sulfur melts. You place powdered sulfur in evaporating dish. You heat then until it melts. That is the first one. Then stir and add more sulfur a little at a time until the dish is almost full. You stir as you add, stir, stir and add little sulfur till the dish is full. You stir as you add a little sulfur. In the process, as you are going to be stirring, you add a little sulfur until the dish is almost full of molten sulfur. Then remove the source of heat and allow the sulfur to cool. Remove source of heat and allow sulfur to cool. Allow to cool. Remove the source of heat and allow the sulfur to cool to form a crust on the surface. So this is what you are going to see. Crystal of monoclinic sulfur as seen using the hand lens. When you use the hand lens, this is the crystal that you are going to see. That is the crystal that you will see. So we have another form of sulfur, a non-crystalline form of sulfur, which is known now let's talk about non-crystalline form of sulfur. Non-crystalline form of sulfur. Most of the students usually forget about these two, non-crystalline form of sulfur, and this is what is usually asked. Non-crystalline form of sulfur. Non-crystalline sorry, the marking is, this marking just needs some communication. Non-crystalline form of sulfur. We have also two non-crystalline form of sulfur. One, we have amorphous sulfur. Then the non-crystalline form of sulfur, amorphous sulfur, and colloidal sulfur. Those are the two non-crystalline form of sulfur. The rhombic and monoclinic are the crystalline form of sulfur, while amorphous and colloidal sulfur are the non-crystalline form of sulfur. So this amorphous sulfur is formed when a solution of hydrogen sulfide is left exposed to air, that is through oxidation of hydrogen sulfide by oxygen. Amorphous sulfur is just formed when hydrogen sulfide is oxidized by oxygen. Hydrogen sulfide is oxidized by oxygen to form amorphous sulfur. It is going to form sulfur. This amorphous sulfur plus water. Amorphous sulfur plus water. This is how amorphous sulfur is formed. Amorphous sulfur is formed when hydrogen sulfide gas, not hydrogen sulfide, is left or exposed to air, and when it is exposed to air, it undergoes oxidation by oxygen to form amorphous sulfur plus water. That's how amorphous sulfur is formed. When you are asked to explain, I'm going to explain like that. Then colloidal sulfur. Colloidal sulfur is formed when sodium thiosulfate is reacted with dilute acid. Sodium thiosulfate is reacted, this one colloidal sulfur, sodium thiosulfate is reacted with dilute acid. Sodium thiosulfate is reacted with dilute HCl to form colloidal sulfur. Sodium thiosulfate reacts with dilute HCl to form colloidal sulfur, water, and sodium chloride. This is how colloidal sulfur is formed. This is how colloidal sulfur is formed. So, something that I've just forgotten, amorphous sulfur, it is insoluble in carbon sulfide. This amorphous sulfide is insoluble in carbon sulfide. Now, let's look at some of the properties of sulfur, then I'll stop from there. Properties of sulfur. You have the physical property. Then let me just talk about the physical properties. Then the chemical properties are just small. Just pass there very fast. Physical properties of sulfur. Physical property of sulfur. That's one I just said I'm not going to write them on the board. So the physical property, we have one, it is a non-metallic solid, it is insoluble in water but soluble in organic solvent. From that physical property, you can be asked a question how you can separate sulfur from another element or another compound, maybe a compound containing sulfur. How is it going to be separated? So you should take note of this physical property, insoluble in water but soluble in organic solvent. Then it's a poor conductor of heat and electricity because it has no electrons which are responsible for conducting this electricity. Then it melts at 113 degrees Celsius and boils at 441 degrees Celsius. Then contains the S8 rings, the sulfur molecules, the S8 rings which I've talked about. Now let's talk about the chemical properties. This one you should take note of the chemical property. Chemical properties. The chemical properties. So, reaction with oxygen. The reaction with oxygen. Reaction of this sulfur with oxygen. Reaction with oxygen. So, as you all know, when sulfur reacts with oxygen, it's going to form sulfur oxide. This sulfur plus oxygen form sulfur oxide. Gas, that both gases. That is the first chemical property. The second one, reaction with carbon. At a very high temperature, sulfur reacts with carbon to form a liquid carbon disulfide. Reaction with carbon. Disulfur plus carbon form sulfur with carbon to form carbon disulfide. Carbon disulfide. Let's mark them. Carbon disulfide. This reaction, it takes place at a very high temperature. That is the second chemical property. The third one, oxidation reaction. Sulfur is oxidized by hot concentrated sulfuric 6 acid and nitric 5 acid. So sulfur plus sulfuric 6 acid, you are going to form sulfur oxide plus water. Then reaction with metal. Sulfur reacts with copper to form copper 2 sulfide, or it can also react with iron to form iron 2 sulfide. Reaction with metal. That is sulfur plus, let's say, iron. Iron is a metal, form iron 2 sulfide. Just like that. So it's not here. It is going to form iron 2 sulfide. Then let's look at some of the uses. Uses of sulfur is used in making drugs. Then it's used in making bleaching agents. Have production of sulfur oxide. This bleaching agent sulfur, it is used to make some bleaching agents, such as you have some drugs which contain sulfur, like the clozol B, which is used in treating some skin diseases. That's all for today. Let's meet in the next subtopic.